Welcome to this deep dive into AI-powered semantic search. We're looking at the sources you provided. Forget just matching keywords. Today we're exploring how AI is starting to understand what you're actually looking for online.
Exactly. And the sources give us a really good map of this whole landscape. We'll break down what semantic search really is, how it works under the hood, where it's making waves, look at the tools enabling it, and yeah, touch on the limitations and what's coming next too.
Right, and the goal isn't just a tech lecture. We want to hit those aha moments, understand how AI gets the intent, the actual meaning behind your search, not just the words. It's a huge leap from, well, what we used to deal with, wasn't it?
Yeah.
Thinking back to older search engines, what were the biggest frustrations?
Well, the main thing, as your sources highlight, was that strict reliance on exact word matches. If you didn't guess the exact right term the content used, well, you'd often miss what you needed. The systems just couldn't grasp synonyms or context or, the why behind your search.
Yeah, it felt like you needed this secret keyword handshake sometimes. I
Yeah.
definitely remember trying endless combinations. And the sources bring up keyword stuffing websites, just jamming keywords in to tweak those old systems. That was annoying.
Oh, absolutely. Because it was just word counting, basically. It was easy to manipulate. Semantic searches, it's a totally different game, a real paradigm shift, as the sources put it. It uses AI, specifically natural language processing, NLP, to move beyond words to meaning, to intent. It's much more human, really.
Okay, so it sounds way smarter. How does it actually do that? What's the tech making it tick?
Yeah, this is where it gets cool. The absolute foundation is natural language processing, NLP. That's the tech letting computers parse and, well, understand human language like we use it, identifying parts of speech, entities, relationship, the point of what's being said.
Okay, so NLP is the language brain. What
Yeah.
else?
Then you have vector representations, embeddings they're called. Think of taking words, sentences, whole documents even, and turning them into long lists of numbers, these vectors. But the key is these numbers capture semantic meaning. Things with similar meanings end up having vectors that are numerically close together in this high-dimensional meaning space.
A map of meaning.
Oh,
That's a
yeah.
neat way to put it. Can you give a quick example?
Sure, like happy and joyful. Different words, but very similar meaning, right? Their vectors would be really close. But happy and, say, screwdriver, totally different meanings. Their vectors would be miles apart numerically. Measuring that closeness, that semantic similarity, is crucial.
Okay, so you got all these meaning vectors. They need somewhere to live, yeah. Somewhere you can search them fast.
Exactly. Enter vector databases. These are specially built databases. Pinecone, Weaviate, even Elasticsearch has powerful vector search now. They're optimized just for storing and indexing these complex vectors. They make finding the nearest neighbors, the most semantically similar vectors, super fast. That's key for search.
Got it. NLP for understanding, embeddings for meaning numbers, vector databases for searching those numbers. What other big pieces are involved?
Transformer models have been huge. BERT, sentence BERT, you might have heard of them. They're advanced AI models that got really good at creating high-quality embeddings. Their trick is understanding context, looking at the whole sentence, not just words in isolation. Gives a much deeper understanding.
And the sources mention knowledge graphs, too. How do they fit in?
Knowledge graphs provide structured knowledge. Think of them like a pre-built network of facts. They connect entities, people, places, concepts with defined relationships. Like Steve Jobs is linked to Apple Inc., which is linked to technology. This gives the search engine explicit, real-world context, helping it understand nuances.
So it's like a built-in encyclopedia the search can quickly check.
Kind of, yeah. A structured one. Many advanced systems use them to boost that contextual understanding, especially for tricky queries.
Okay, great. So we have the main ingredients. How does this all come together? Like, what's the actual flow from raw data to me getting search results?
It generally breaks down into two main stages, as the sources describe: offline indexing and then the online query part.
Let's start offline. What's happening before I even type anything?
Okay, so offline indexing. First, the system gathers all the data documents, web pages, product info, whatever needs searching. Then it pre-processes it, cleans it up, breaks it into manageable chunks, maybe paragraphs or logical sections, makes it easier for the AI to work with.
Makes sense. Can't just throw a giant messy file at it.
Right. Then comes the embedding generation. This is where those NLP models, often the transformers, step in. They read each chunk and convert it into its unique numerical vector, capturing its meaning. Finally, all these vectors get loaded and indexed into the vector database, ready for fast lookups later.
Okay, that's all the prep work. So now I go to the search bar, type my question. That starts the online phase.
Correct. Online query phase kicks off. First step, process your query. Your search terms get converted into a vector too, using the exact same AI model that processed the documents. This is critical. It puts your query and the potential answers in the same semantic language.
Right, so my question gets its own meaning vector. Then what?
Then the system queries the vector database. It does that similarity search we talked about. It finds the document vectors that are mathematically closest, the nearest neighbors, to your query vector. These are the documents most semantically aligned with what you asked.
And are those the results I see immediately?
Often, but there's usually one more step, re-ranking. It's optional but common. Here, the semantic scores from the vector search can be combined with other signals, like maybe traditional keyword relevance still matters a bit, or the source's authority, or how recent it is. Blending these helps fine-tune the final ranking for the best possible results.
So it's often a hybrid approach. Using the semantic smarts, but maybe also some tried and true methods. That seems sensible. The sources also called out specific features within these systems, like semantic ranking itself. What's that exactly?
Semantic ranking is just that scoring results based on how well their meaning matches the query's meaning. It uses those language models to gauge conceptual fit, not just word overlap. Some platforms, like Azure AI Search, even give you an explicit score for this.
And what about semantic captions and highlights? Saw those mentions.
Yeah, those are super helpful for you, the user. The system finds the specific sentences or phrases within a result that best explain why it's relevant to your query. It might even bold the key terms in that snippet, lets you quickly judge if you need to click through. It's all about providing context up front.
That sounds way better than just a title and a generic description that might not tell you much.
Totally. And then there are semantic answers. For certain kinds of questions, the system can sometimes find and pull out a direct word-for-word answer from one of the documents it indexed.
Oh, kind of like those featured snippets you see on Google sometimes.
Similar idea, yeah. But the key difference here is these semantic answers are extracted verbatim from the source text. They aren't generated or made up by the AI like you see with some newer generative models. It's finding existing answers.
Got it. Important distinction. So this tech clearly has legs. Where are we seeing it used most effectively? What are some real-world impacts?
Oh, it's spreading everywhere. E-commerce is a big one. It changes how you find products. Instead of exact names, you can just describe what you want, like warm winter coat that's waterproof but not too bulky. The system gets the intent. MileSearch, for example, has shown big gains in product discovery. And giants like Amazon and Netflix, they heavily rely on semantic understanding for search and recommendations. It drives sales and keeps users happy.
Makes total sense. Online shopping search has gotten much better at figuring out what I actually need. What about more specialized areas?
Huge impact in healthcare and life sciences. Imagine researchers trying to find relevant studies in massive databases. Semantic search understands complex medical terms and relationships. Elsevier's SciBite Chat, mentioned in the sources, uses ontologies and LLMs for faster R&D. It can really accelerate finding crucial information.
Wow, speeding up medical research. That's significant.
Yeah.
Any other big sectors?
Legal and compliance, definitely. Searching through case law, contracts, it's a nightmare usually. Semantic search lets lawyers find related concepts even with different wording. Pinecone worked with Voyage AI on a legal app, helping find precedents for things like workplace discrimination much faster.
That sounds like a massive time saver for legal teams. Anywhere else?
Customer support is another key one, powering better chatbots, smarter knowledge bases for support agents, better self-service portals. The system understands the customer's problem description in natural language, not just keywords. It finds the right help docs or FAQs, often uses ARG retrieval augmented generation to help draft replies too.
So it's really understanding the issue, not just matching words in a support ticket.
Precisely. And beyond that, marketing uses it for SEO, content discovery, education for searching course notes by concept, media for finding video clips, and enterprise search helping employees find internal company knowledge. Basically, any place with lots of text data can benefit.
It really feels like it's becoming foundational technology. So who are the main players building these tools? What platforms are out there?
It's a busy space. You've got established players like Elasticsearch and OpenSearch. They've added strong vector search and even built-in ML for NLP, like Elasticsearch's ELSER. They offer that hybrid approach, mixing keyword and semantic.
Right, the established search engines adding new tricks, and those dedicated vector databases.
Yep, companies like Pinecone and Weaviate are specialists. Their whole platform is tuned for fast, scalable vector similarity search. Crucial for real-time stuff, especially RAG. Then there's Vespa.ai open source, known for handling huge scale and custom ML ranking.
So a mix of big platforms adapting and focused startups. What about the big cloud providers?
They're all in. A Google Cloud Search has AI-powered enterprise search, multimodal capabilities. Azure Cognitive Search is comprehensive semantic ranking, AI enrichments, tight integration with Azure OpenAI. Even platforms like ServiceNow are embedding semantic vector search. And you have search as a service providers like Algolia, Amazon Kendra. They offer managed solutions with lots of AI features built in.
Wow, okay, lots of options.
Yeah.
But it can't all be smooth sailing, right? With all this complexity, what are the downsides? The challenges?
No, definitely not perfect. A big one is complexity. Implementing and tuning these systems. It takes real expertise in AI and NLP. It's not plug and play simple. And the computational cost.
Yeah.
Processing language, running vector databases. It needs serious hardware and resources. It can be expensive.
Yeah, those AI models don't run on pocket calculators. What about accuracy? Does it always understand what I mean?
Not always. It can stumble on really subtle stuff, sarcasm, idioms, very ambiguous phrasing where your intent just isn't clear. And performance really hinges on the training data. If the data used to train the AI was biased or low quality, the results can be inaccurate or skewed. Privacy is a concern too, especially when user data is used for personalization. And there's always this balancing act. Precision versus recall, getting the top results spot on versus making sure you don't miss anything relevant further down.
And you mentioned a limitation with how ranking sometimes works.
Right. Sometimes semantic ranking only gets applied to, say, the top 50 or 100 results found by an initial, maybe simpler search method, not the whole data set. Also, remember, these systems find existing information. They don't create new facts or synthesize insights like generative AI might claim to. The answers and captions, they're pulled directly from the source material.
Right. Finder, not creator. Good distinction. Looking forward then, what's happening at the cutting edge? Where's the research heading?
Oh, lots of exciting stuff. Improving contextual retrieval, especially for RAG, is huge. Making the system better understand the context of your query, blending semantic with traditional methods like BM25. There's also work on semantic pseudo-relevance feedback using the meaning of the first batch of results to automatically refine the search query and try again, getting smarter.
So the system learns from its own results to search better. Cool.
Exactly, and we're seeing more powerful large language models, newer BERTs, GPTs being used directly for retrieval, handling longer text, adapting better to specific fields. Plus, moving beyond text, multimodal search, images, audio, video, and conversational search, having back and forth interactions. And of course, that deep integration with generative AI, where semantic search finds the right knowledge for the LLM to use in its response, that's a massive area.
Feels like the way we find information is going to keep changing pretty rapidly. The sources had some great case studies too. Can you recap one or two key impacts?
Sure. That Pinecone legal app shows how finding precedents based on intent transforms legal work. Google, using BERT, improved understanding for millions of searches, huge-scale impact. Netflix and Amazon using semantics for recommendations and product search drives real business value. Elsevier's SciByte chat shows the power in specialized R&D by combining ontologies, LLMs, and semantic search. And those customer support improvements, faster help, better self-service, directly impact user satisfaction.
Those really drive home the practical value. Now, a critical piece must be making sure the results are actually relevant and make sense in context. How do systems aim for that?
It comes back to those ranking algorithms using vector similarity, like cosine similarity, to measure conceptual closeness. Machine learning is also used, training the system based on which results users actually click on and find helpful. And using context clues is vital. Your location, maybe past searches, the other words in your query all help figure out the specific meaning you intended. Plus, techniques like query expansion, adding synonyms, and using knowledge graphs for relationships, they all boost that contextual accuracy.
We touched on this, but training data and cost seem like big factors for anyone implementing this. Can you expand on that a bit?
Absolutely. You need good data to train these models, lots of it. High quality, diverse, well labeled. There's often a lot of work just preparing data and fine-tuning models for a specific need. And yes, the computing resources, GPUs, memory, storage for vector databases, it all adds up. It's a significant investment. But there are ways to manage it using open source tools, pre-trained models as a starting point, optimizing database queries, maybe using smaller transformer models or serverless setups. It's about finding the right balance between cost and quality.
Right, that trade-off again. Okay, finally, just to paint a clear picture, can you list a few more concrete examples of search engines using semantic search across different areas?
You bet. General web search, Google, Bing, DuckDuckGo are all deep into semantics. Academic search. Semantic Scholar is a great example built on this idea. E-commerce. We mentioned Amazon, but also platforms using tools like Algolia, Monotate, Bloomreach, Milasearch, enterprise search inside companies. Amazon Kendra, LucidWorks are players there.
And those AI assistants, Perplexity AI, ChatGPT, Search, U.com, Microsoft Copilot, they lean heavily on semantic understanding for their conversational search.
It really is everywhere, powering so much of our information access now. Okay, let's wrap up this deep dive. What are the main things you want listeners to take away about AI-powered semantic search? I think the main point is this. Semantic search is a really big step forward. It's moving beyond just matching words to actually understanding meaning and intent. This leads to much more relevant results, a better experience for you, and it's enabling new things across so many industries. Yes, there are challenges, complexity, cost, getting the nuances right, but the research is moving fast. Things like better context, integration with generative AI, it's only going to get more powerful and intuitive. It's fundamentally changing how we interact with information, making it feel more natural, more human.
So we've just taken a pretty thorough look at AI-powered semantic search. Hopefully you've got a clearer picture now of how machines are getting better at understanding us, leading to way more useful search results. Maybe think for a second about how this affects your own searches day to day, or the potential in your job or industry. What questions does this spark for you about where information access is headed? It's changing fast, like we said, so there's always more to learn. Might be worth looking into some of those platforms or research areas we mentioned. Thanks so much for joining us on this deep dive. We really hope it gave you some valuable insights into this fascinating spot where AI meets information retrieval.